All right, so we're finishing up the last section of this unit, and we're going to be graphing those logarithmic functions. So we've talked about how to interchange between exponential and logarithmic functions. We've looked at graphing exponential functions, and so now we're going to look at what do logarithmic functions look like. So a basic logarithmic function you'll see at the top is y equals log base b of x, where b cannot be equal to 1. And so some of those characteristics of a parent function. So if we were looking at just this parent function, the domain is the set of all positive real numbers. The range is the set of all real numbers. That y-axis is going to be the vertical asymptote. Now, by asymptote, we mean values that it approaches but doesn't ever reach. So when we talk about an asymptote, we're talking about the value a graph approaches but never reaches. Again, much like what you saw in the exponentials where you had that approaching that value. And again, it should be because these are inverse operations of one another. Keep in mind when we talk about inverse operations, we're talking about that reflection over that y equals x line that we talked about in last unit. And then of course for the parent function of this one, the x-intercept would be at 1, 0. So if you wanted to put in a value for b, you could see what was happening with this classic parent function. All right, so what we're going to do is we're going to, for example 1, we're going to look at the parent function as well as the transformed function and see how do they relate to one another. So the first thing I'm going to do is I'm going to sketch the parent function. So when I think about the parent function of the function that you're seeing would be y equals log base 2 of x. And so what you're going to do here is you're going to put that into your graphing calculator. So like we've shown before, you're going to go into that y equals option. So press y equals, and we're going to put in that parent function. So you're going to put in your log base here. So go to math, do your log base option again. I'm sure you're tired of hearing me tell you how to do this. Put in your 2 and then arrow over, and now instead of putting a number, you're going to put in x. And then you're going to hit graph. Now what you're going to notice is that you get a shape to it that looks, basically like it's approaching a number on one side and then heading to infinity on the other side. So if we want to look at specific values, you can hit second and graph, and that creates a table of values for you. You can arrow up and down, and so I'm going to arrow up all the way up to some negatives. And when I get into those negatives, you'll see that there's an error. The error actually starts at 0. And so if I come down, the first value in your table of values, you should see a 1, 0. So I'm going to go ahead and graph that point. So here's what my table looks like. I have -3 and I have an error, and I have -2 and I have an error, and I have -1 and I have an error, and I have 0 and I have an error. And then when I get to 1, 0, that's where I first see that ordered pair that I can graph. Okay, and I'm just going to look at nice integer values. So then I have a 2, 1, and then if you keep arrowing down, you'll see that you have a 4, 2. And so when I graph those, there's my 1, 0, then I graph my 2, 1, then I graph my 4, 2. And I'm going to scroll down and see if I have any other integer points that would make it on this graph. And I do. I have 8, 3. And so I'm going to graph 8, 3. And that's probably going to do it. And so I get a graph that looks like this. Now, the question becomes, it doesn't start at 1, 0, though. It's approaching that value. And so what happens here is we're approaching a value. And so that value we're approaching is where it comes over to that next integer. And we're going to keep these very basic for you. Now in pre-cal, you're going to get to more complicated logarithmic functions. But for now, we're going to make this approach that next integer over, which would be approaching 0. And so this is going to keep getting closer and closer and closer. Now, when you look in your calculator, it isn't going to show it that way. So the graphing calculator, it gets so close that it doesn't show you once it gets to really, really close values of 0. So when you graph it, you want to make sure that you do in fact show this part that it's getting really close to 0, and that you have an arrow indicating that it's going to keep approaching and getting closer and closer to 0 but never touch it. All right, now what happens as we look at the new function? So our new function from the parent function was 4 times log base 2 of x. Now what you should notice is that that 4 would count as that stretch that we've talked about, that vertical stretch, like we've talked about transformations in every other function we've talked about this year. So what I would expect is that this is going to have a vertical stretch of 4, meaning that I'm going to have a kind of elongated look. So I'm going to go ahead and put that into my y equals and pull out a table for that. And so you can either leave in your parent function, but if you don't want to confuse it, you can certainly delete your parent function and put in your 4, or you could have inserted the 4 in front of what you already had there if you know how to do that. Anyways, you're going to put in your 4, then do your log base again if you're redoing this, and put in 2, and then your x again. And then you're going to hit graph again. And you're going to notice that this is this has stretched. It has had a vertical stretch of 4. So if you go into your table, which again is second graph, you go into your table and you arrow up, you're going to notice that you get errors again. So -2, -1, 0, I see errors. And then my first number I see is a 1, 0. I'm going to move this up just a little bit, guys, so I can quit making that eraser come up. All right, so then I have 1, 0, and then I have 2, 4, and then I have 4, 8, and then as I arrow down, 8, 12 is going to go off. So that's where I'm going to stop. And so then I'm going to go ahead and graph these. I'm going to scroll back down or back up just a little bit to see where I'm at. And so then from there, I'm going to graph these points. So 1, 0 would be my first point on the new one. Then I have 2, 4. And I have 4, 8. And you can definitely see the stretch there. And so when I go to connect this, it's that same thing. It goes like this. And then what happens is, again, it's approaching that value, that integer. So again, where the error occurs first is the value that it's approaching. And again, we're going to keep these nice integers for you right now. So the 0 is where the error occurs because we're not getting to 0 on the original parent function, which is why it's approaching 0. And same thing down here. 0 is your first error that you see. So it's never going to get to 0, but it's going to approach that value. So when I go to make this, I'm going to make this look the same way, but I'm going to stretch it down a little bit because I know it has a stretch to it. And I'm going to bring this down a little bit further and just keep making that look like it's approaching that 0, never getting to it. And once I get close, that's where I'm going to use my arrow. And so what you're looking at is that vertical asymptote. So in this case, the 0 basically acts as that vertical asymptote. Again, a vertical asymptote means a vertical value that the graph is approaching but never actually reaches. And so that's what you're seeing in these logarithmic functions. And so that's why these arrows here down here are so important, because it's approaching that vertical asymptote of 0, because that's the value that the graph says it's getting close to but never gets to. All right, so moving on to example 2, we're going to take a look and see what this looks like. So again, if you think about the sketch of this, okay, what does it look like? So we're not going to graph the parent function this time. Now, the parent function would basically be, that without that stretch and without that translation. So if we were thinking about the parent function here, sorry guys, I'm not sure where that keeps flipping over. If we were thinking about the parent function here, we would have y equals log base 3 of x. Now, again, we're not going to do the parent function, but this should tell you that it has a stretch of 4 and a translation right of 1. Again, just like the transformations have been in our previous functions, we're going to see the same type of transformations in these functions. So the 4 would count as that vertical stretch, and that 1, because it's inside with the x, would count as our horizontal translation, and that horizontal translation would move right 1. All right, so what I'm going to do, I'm going to basically put it into my graphing calculator. It makes it very easy. You're going to use the technology to your benefit. So you're going to put into y equals, I'm going to clear out that last function. I'm going to put a 4. I'm going to go down to my log base under my math option again, pick log base, and I'm going to do log base 3 of x minus 1 in parentheses. All right, then I'm going to hit graph. I'm going to get an idea of what it looks like, and so you can see that it's approaching a value again. It looks similar to the last one. It's approaching a value, and we're going to figure out what is that value approaching now. It looks like it might be 1 that's approaching, but I'm going to make sure through my table of values. So now this time, and again, that should make sense, right? It was approaching 0, and I said before as we started this problem that transformation of that translation right 1 would make sense, that instead of the vertical asymptote being 0, the vertical asymptote would now be 1. And so let's go into our table and look at that. So again, I'm going to arrow up till I see some errors. And so here's my table of values again. I'm not going to put a bunch of them, but -1, 0, and 1, and I see errors for all of those. Now my first error that I see is 1, which is exactly what I expected, because this is what the number it's approaching. That's again that vertical asymptote that I'm looking for. So that's the value it's going to approach. All right, then when I get to 2, I see that I get a nice number for 2, which is 2, 0. Then I get 4, 4. And then if I arrow on down, I see that my next value would be 10, 8, and that's going to be the last one that actually sits on this graph that we can see. All right, so I'm going to go and graph 2, 0. I'm going to graph 4, 4. And I'm going to graph 10, 8. And so there's that graph again that I see that same shape happening again. But then it becomes, what is the value approaching? And so it's approaching that value of 1 because we've shifted it from the parent function where it would have approached 0. Now we're shifting everything over 1, meaning that now instead of a vertical asymptote of 0, we're going to approach a value of 1, and that vertical asymptote is going to be at 1. And so we're going to make that look like it's approaching, getting really, really close. And once we get to the point where we're pretty close and we can show with an arrow that it's going to keep approaching that value of 1 but never reach it, that's where we can stop. All right, and then last one, again, what you're going to notice and what we're looking at is we get into now a stretch, a horizontal translation, right 3, and a vertical translation down 2 from the parent function. Now, again, we're not asking you to get real complicated with these transformations, so you can go into y equals. You can put in your new function of 2, go to your log base, and do a log base 4 of x plus 3. And then make sure that you arrow over out of those parentheses and put a minus 2. That way we can make sure that that's an actual vertical translation down 2. Now, again, if you want to see it, you can hit graph, and you get an idea of what it's doing. So again, it's that same thing. It has that same general shape. You do see hopefully on the left side of the graph that it's approaching, and it looks really odd here because it just stops in the middle of the graph. And it's because it's getting so close to that value of -3. And again, it's what we expected. You should see that that's a shift left of 3. So where the vertical asymptote of the parent function would have been at 0, we're now shifting left 3, creating a vertical asymptote at -3. And so that's exactly what we see. But we're going to go into our table of values just to make sure that it's showing the same thing we expect. And so as you go up, you'll notice that -3 is that first value of error. So again, if I make a table of values and I have -5, I see error because it's not going to get there, a -4 with an error because it's not going to get there, a -3 with an error because it's not going to get there. But that's my first value that creates the error, meaning that that's what it's approaching but never reaches. So that's where that vertical asymptote is going to sit again. And so then we have a -2, a -2, and then we get a nice -1, -1. And then our next nice clean integer that we can graph would be 1, 0. Again, we could graph decimal values, but just to make it nice and clean and accurate, we're going to use those integer values. We get another value at 5, 1, and then what you'll notice is that everything from there, the next value would be at 13, 2, and that's going to go off our graph. So we're going to graph our -2, -2. All right, then we're going to graph -1, -1. Then we're going to graph 1, 0. And then we're going to graph 5, 1. And again, you can see what that graph's doing. It's got that shape. This one's obviously a much flatter type of curve because we don't have near as much stretch as we had in the last two. We don't see that heavy stretch like we did with the 4s. So this one isn't going to have near the dynamic of the stretch that the previous two did. So you're going to see the stretch is obviously less because it's a 2. And then we're going to finish this value out. And again, the graph looks kind of odd in the calculator. So the graphing calculator isn't going to show you how far that comes down. So again, what's happening is this is my vertical asymptote. That -3 is what I'm approaching, but I never reach. So I'm going to make sure that my curve starts to approach that -3. And then I'm going to just draw that nice arrow saying, hey, I know this is going to keep going on towards -3, but it's never going to get there. So watch for your vertical asymptotes. Again, asymptote is a new word. It's a value that a graph approaches but doesn't reach. And so as you're thinking about those vertical asymptotes, you want to think about how does that apply in your logarithmic functions. And so you do want to show that those are approaching those integer values where the error first occurs because it doesn't actually reach that number, but it approaches that number.